Now let us move for the another transformation, which is our y equals to minus of fx. Y is equals to minus of fx. In this case, what you will do, first you will draw the basic graph and then just rotate the graph about the x-axis by 180 degrees. Is it clear? First you draw the basic graph for y equals to minus of fx. Let me just take an example like minus of sine x, let us say. So what I will do, I will first draw the basic graph and then I will rotate it about the x-axis by 180 degrees. So y equals to sine x, which is our basic graph. If I draw it, how it will look like? Is it clear? Now what I am trying to do, now I am transforming it as y equals to minus of sine x. So what I will do, I will rotate the graph about the x-axis by 180 degrees. So the final graph will look something like this. Tell me yes or no, and this thing goes on. Is it clear? Just rotate it by 180 degree, you are going to get the graph something like this, which is nothing but your y equals to minus of sine x. So this is how we draw the graph of y equals to minus of fx. The next transformation is y equals to f of minus x. F of minus x. Okay. Let us take an example. Let us say y is equals to what to say? Okay, log base e minus x. Okay, log base e minus x. Now, one thing you can ask me right now is, sir, how dare you are to write minus inside log? Because as you told us that your x, log x, that x cannot be negative. But here you have taken minus x. So inside the log, how negative sign is possible? Now you will see, now you will understand how your graph speaks. Think about it. If x is negative every time, then this log of minus x is defined. It's very much defined. Now your graph will say that your x in this case for this graph will always take the negative value. It will never take any positive value. That graph will speak. I will not say anything. Okay. But before that, you must know how to transform the graph of y equals to f of minus x. First of all, you draw the basic graph and then you rotate the graph about the y-axis by 180 degree. What was your f of y equals to minus of fx? In that case, you have rotated the graph about the x-axis by 180 degree. In this case, in the case of y equals to f of minus x, you will rotate the graph about the y-axis by 180 degree. So, let me draw the basic graph first. Log x base e. What is the basic graph? The basic graph will be something like this. It is 1, 0. Is it clear? Now we have to draw the graph. We have to transform this graph as log base e minus x. So x is with the minus sign. That is f of minus x transformation we are trying to do here. So what we will do? We will just hold this y-axis and we will rotate it by 180 degree and the final transformed graph will look something like this. Tell me yes or no? Yes or no? Absolutely. So that is the final graph of y is equals to log of minus x. Now you observe carefully. Is there any x in the positive direction on the x-axis where you will get the corresponding value of the function? No, because there is no curve. So you will not get the value of y in that case. But every time you observe, if you take x as negative, you are going to get the corresponding values of y. That is why I told you, whenever minus sign is inside the log, in this case, your x cannot take any positive value. That graph itself is speaking of. Okay, so all the x that you will take are negative, right? So that is why this function is very much defined, and the final graph will look something like this. Is it clear to everyone? Okay. Now, the next transformation is there is no place to write. Let me write it here. Y equals to a times fx. Y equals to a times fx. Okay. Let me just draw the graph of y equals to 2 sine x. Listen it very carefully. First you draw the basic graph in the is sine x. This is the sine x graph, right? What about this point? 0, pi, 2 pi, 3 pi, minus 2 pi, minus 3 pi, and this thing goes on. And this point, all this will be what? Okay? This point is nothing but your 0, 1. And this point is nothing but your 0, minus 1. That is why we have been saying that your sin x will never cross the value 1, minus 1 and 1. It will never go down. It will never go below minus 1. It will be never above 1. Okay? Now, if we go for the transformation of y equals to 2 times sin x, what you do is, you just stretch the graph along the y-axis by 2 times. Okay? So 2 times you stretch the graph along the y-axis. Remember, there will be no change on the x-axis. That is, the points where the curve is touching the x-axis will remain as it is. Only the stretched portion will be along the y-axis, not along the x-axis. Therefore, if we stretch the graph by 2 units, so the final graph will look something like this. Yes or no? Tell me. Right? This point is again 0, pi, 2 pi, because all these points on the x-axis will remain same. It will not change. Only this portion changes, because you have already stretched along the y-axis. So now this point will be your 0, 2. Okay? This point will be 0, minus 2. Have you understood this? So whenever you have y equals to a times fx, you stretch the graph along the, though this portion is not correct, it will go up a little bit. Okay? But you have understood, right? So whenever it is a times fx, what we do, we stretch the graph along the y-axis by a units. Remember, keeping everything as it is on the x-axis. That is, wherever the curve is touching the intersecting or touching the x-axis will remain as it is. I mean, the coordinates will remain as it is when you are stretching the graph along the y-axis in the case of a times fx. Is it clear to everyone? Okay. Now let us come for the last transformation, which is y equals to f of ax. Is it clear? That is, suppose I have given you to draw the graph of y equals to sine 2x. This graph we have to draw. So what we will do is, we will draw the basic graph. This is our 0, pi, 2 pi, 3 pi, minus pi, minus 2 pi, and this thing goes on, right? Now, we have been given sine 2x. Remember it. Whenever you have f of ax, what you do is, you contract the graph along the x-axis without affecting the y-axis. Is it clear? You will just contract the graph by 2 units on the x-axis. That is, this point which was previously was pi, this time it will become pi by 2. It was previously 2 pi. When you have contracted by 2 times, so it will become only pi. Is it clear? This was your 3 pi previously. Now it will be 3 pi by 2. In this case, it was minus pi previously. Now it will be minus pi by 2. And in this case, it will be minus pi. Is it clear to everyone? But remember, without affecting the y-axis, that is, this point was what? 0, minus 1. This point is 0, 1. It remains as it is in this case. You have just contracted the graph along the x-axis by 2 units. That's it. Without affecting the y-axis. That is the method of transformation of y equals to f of ax. Is it clear? Now, the same thing if I give you, let us say for y equals to f of x by a. Let us take an example like y equals to sine x by 2. Then what you will do? First you draw the basic graph. This is what? 0, pi, 2 pi, 3 pi, minus 2 pi, and this thing goes on, right? Now it is x by 2. Listen it carefully. All you do now is you elongate the curve along the x-axis by 2 units without affecting the y-axis. Is it clear? You just elongate, you just stretch the curve by 2 units along the x-axis without affecting the y-axis. It was your 0, 1 and this point is 0, minus 1. These points will not be affected. Only since you have stretched the curve, you have elongated the curve, this point was previously pi. In this case now it will be 2 pi. This was 2 pi, now it will be 4 pi. This was 3 pi, now it will be 6 pi. This was minus pi, it will be minus 2 pi. In this case, it will be minus 4 pi, and this thing goes on. Is it clear to everyone? Have you understood this completely? So this is how we go for the transformation of y equals to f of x by a. Is it clear?